the neuroscience of intelligence and how it works. Let's start out by looking at the neuroscience of intelligence and precisely how you can go about increasing it from a theoretical standpoint. So welcome to your brain. Here, you have a massive interconnected web of neurons, which we collectively refer to as your connectome. Think of this like the world's largest mind map, except that it is made from billions of connections. Each of these neurons represents an experience, an action, a memory, or a qualia. So for instance, you have your visual cortex, V1, which contains all the neurons responsible for your sight. If you were to open up the back of your skull and stimulate those neurons individually using an electrode, this has actually been tested by the way, then you would see points of light appear in your vision, corresponding to the specific neuron. Likewise, if you were to stimulate neurons in the motor cortex, then this would cause your arm or leg to move, or it might make you feel a sensation on your ear. Other neurons have different jobs. For instance, there are those that have the role of storing memories. These light up when we recall things that happened to us in the past. Others might make us feel happy or sad. Others might represent aspects of our personality or our ideas. These are grouped into clusters in the brain or brain regions, which is why brain damage can end up knocking out very specific abilities or altering our personalities. And at any given time, multiple brain areas will be active, representing the way in which your brain is being used. So you might have activity in your visual cortex, because you are processing the things around you. But you might also have activity in your hippocampus, relating to memories associated with the things you're seeing. And you might have activity in your prefrontal cortex, as you make plans as to what you're about to do. Neurotransmitters. The neurons are connected via long tails and branches called axons and dendrites. They don't actually come into physical contact with one another, but rather they come very close to touching and leave just a very slight gap called the synapse. When one neuron fires, it causes all of the surrounding neurons to become more excited. And when neurons pass a certain excitement threshold, then they fire too. So in other words, you might see a duck, and this might register as a representation of a duck in your mind's eye. That causes a certain pattern of neurons to fire. And those action potentials, the technical term for these electrical charges, will then travel down the axons to related concepts that are connected. These include the likes of memories you might have about ducks, opinions about ducks, duck facts, Donald Duck, etc. But only when enough activity surrounds your Donald Duck cluster of neurons will those actually light up, and only then will you experience a memory or thought of the character. Neurons can become excited, but they really only have two states, on or off. What's less binary, though, is the signal that they send and receive. And this is where neurotransmitters come in. Neurotransmitters are chemicals that exist in the brain that effectively add color and nuance to the communications happening across our brain. These act like hormones, in that they are able to change our mood and change the way we feel about something. The difference is that they have a much shorter lifespan and that they act on the brain specifically. Among other things, neurotransmitters make neurons surrounding them more or less likely to fire, and will thereby put the brain in an overall more excited or more inhibited state. At the same time, though, they can also increase the likelihood of new connections forming, and they can increase the apparent importance of certain activity, thereby directing your attention. An example is dopamine. Dopamine is an excitatory neurotransmitter, which means that it makes us more aroused and more awake, and it increases the chances of neurons firing. When dopamine is released in a part of the brain, which causes us to become more focused on whatever is happening right there, because it tells us that thing is important and worthy of our attention. At the same time, dopamine increases our likelihood of remembering that event, because it makes connections in the brain more likely to form. Finally, dopamine makes us more likely to remember things that happened, and more likely to stay motivated. Dopamine is often described as a reward neurotransmitter, but it would be more accurate to say that it is released in anticipation of reward. Other neurotransmitters include the likes of serotonin, the feel-good hormone, of cortisol, the stress hormone, and of oxytocin, the love hormone. All these change the way we subjectively experience the world, and their impact on the nature of the physical change that occurs within the brain. Brain plasticity. An area that has been extensively studied by psychologists and neuroscientists in recent years is a subject called brain plasticity, or neuroplasticity. This refers to the brain's innate ability to change shape in response to stimulation and activity. So previously, we believed that the brain was a set shape once we reached adulthood, and that it wouldn't change any further. What we now know, however, is that the brain continues to grow and adapt as we get older, and that it is constantly forming new connections and even birthing new neurons. In studies, it has been shown that repeatedly engaging in a specific activity will cause the corresponding brain area to change shape. For instance, if you learn to play the cello, then the areas in your motor cortex that are responsible for the sensation and dexterity in your fingertips will get larger and more complex. Likewise, if you play computer games repeatedly, then the brain areas that have responsibility for your ability to make out small details on the horizon will improve. Taxi drivers have physically heavier brains than any other professionals because they change shape in order to accommodate all the new routes and destinations that they commit to memory. There is a simple rhyme you can remember to understand the way that plasticity works, and that is, neurons that fire together, wire together. In other words, if you continuously repeat the same action over and over again, then eventually the corresponding neurons will wire, so that you have committed that sequence of movements to memory. If you eat a lemon every time you see a certain picture, then you will eventually associate the picture and the lemon so that seeing the picture causes you to get a bitter taste in your mouth. The corresponding neurons fire at the same time so often that they now have a connection, and now activity in one neuron will increase the chances of the other firing. What's more is that repeating this connection will reinforce it over time. This occurs via a process called myelination, which basically means that the axons are being insulated to protect them against damage and to help the signal to travel more quickly and more efficiently from one neuron to the next. This is how we learn new subjects, and it's why someone who has serious memory loss can sometimes still perform tasks like playing complex piano concertos. They simply repeated the movement so many times that they became highly myelinated and protected. What to do with all this information? That's a lot of information to take in, and you might be wondering what it's all for. Well, rest assured that this information is important, and we have tackled it for a reason. That's because knowing the way your brain works is what is going to allow you to increase your IQ through training, diet, and more. Hopefully, you've already seen some opportunities for us to maybe tweak and enhance your brain performance. For instance, increasing dopamine can boost our memory and our focus. Likewise, you might have guessed that increasing the rate of brain plasticity might also be a very positive thing. And those are exactly the topics we'll be tackling in the coming sections of this training. So keep reading and get ready to enhance your brain power.